Welcome, guys. Today's notes is on right triangles and some basic trig. If this looks familiar, it's because you've already covered it. And during the summer, you did a little bit of trig. We said SOHCAHTOA, not SOHCAHTOA. That's just nasty, guys. SOHCAHTOA. Where the S stands for sine, the C stands for cosine, the T stands for tangent, the O stands for opposite, the H stands for hypotenuse, and the A stands for adjacent. I think I already mentioned adjacent once, so there it is. So yeah, guys, that's all it is, guys. Pretty basic stuff. So let's go ahead and just get started. Let's go right into it. So I have here sine A. So I'm going to label some stuff, guys. I'm going to put this 3, 4, 5, and I think the best way is just to go right into it. Notice that these are ratios or something over something. So sine A, you look where angle A is at, or vertex A is at. So vertex A creates angle A. And you say, all right, sine A, and you have your SOHCAHTOA here, and sine A is just opposite over hypotenuse. So opposite is 3, hypotenuse is 5. Opposite of what? Opposite of that angle. See? So there it is. Cosine is adjacent over hypotenuse. Adjacent is just a fancy word for next door. What's next door to vertex A here? It's number 4. Yeah, so you can say 5 as well, but 5 already has a name. It's a hypotenuse. So it's going to be 4 over 5. And then tangent. Tangent is opposite over adjacent. So 3 over 4. And then you have these right here. How do you pronounce them? The CSC, you pronounce it cosecant. The SEC, you pronounce it secant. And the COT, you pronounce it cotangent. And the cosecants are reciprocal of sine, guys. CSC, cosecant of A is the reciprocal of sine. So all that means is just take the reciprocal of the number. So if I have sine that's equal to 3/5, sine A, cosecant of A has to be equal to 5/3. And that really is all it is, guys. Secant is reciprocal of cosine. So this has to be the 5/4. And then cotangent is reciprocal of tangent. So that's 4/3. And yeah, it's that simple, guys. No joke. It's pretty simple, straightforward. So here's angle B. So sine B is 4 over 5. Cosine B adjacent over hypotenuse, so that's going to be 3 over 5. And then tan B is going to be 4 over 3. And then cosecant B is the reciprocal of sine B, guys, so that's going to be 5 over 4. And then secant B is going to be the reciprocal of cosine, so it's going to be 5 over 3. And then cotangent B is going to be reciprocal of tangent, so that's going to be 3 over 4. And yeah, it's pretty straightforward, I think. I don't think we have any issues. That's a cute smiley face there, so I'm going to give myself some extra points. So yeah, what do you guys think?
Good.
Yeah, pretty straightforward. Nothing crazy. Let's keep going. I hope no one has OCD. I think it's called OCD. I'm not sure. If you notice, the font here is totally different than the font here. That's because I took this from a geometry curriculum excerpt, and I want to give credit where credit is due. I think this belongs to Gene Adams. I think that's who originally wrote the curriculum. And I just took this little snippet there, just these 2 questions. It's the same curriculum that you guys used when you guys were in geometry. So you probably recognize these questions. And it says, give each trigonometric ratio as a fraction in simplest form. And I probably didn't have to necessarily take this. I just wanted to show you guys that you guys have done this before. Does this look familiar to you guys or no? At least I hope it's familiar. Yeah, I hope it is. All right, so let's just do those real quick. This is a special right triangle, guys. Let's see. Oh, well, they're all special, I guess. 5, 12, 13. All right, sine A. Opposite over hypotenuse, so that's going to be 5 over 13. It does not reduce, so leave it alone. Cosine A, 12 over 13. It does not reduce, leave it alone. And then tan A, 5 over 12, and that does not reduce, leave it alone. Let's go to the C vertice, or the angle at C. So sine C is opposite over hypotenuse, 12 over 13. Done. Cosine C is 5 over 13. Adjacent over hypotenuse. And then tan C is opposite over adjacent, 12 over 5. And that's it, guys. All right, question 2. Question 2, we got to figure out this guy first. You probably recognize it from like a 3, 4, 5 triangle. It's like a scale factor of 3 here. 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. So that's a 15. If you don't recognize that, or if you don't remember that, you could always just have done 9 squared plus 12 squared, and you would have gotten 15 if you take the square root of that. So there we go. Now this will reduce. So sine W, here's W there. So it's going to be 12 over 15. And 12 over 15 does reduce. Let's see, 3 goes into 12 4 times. And then 3 goes into 15 5 times, so 4/5. Cosine W, so it's adjacent over hypotenuse. So 9 over 15, so 3/5. That reduces to 3/5. And then tan W is 12 over 9. And that reduces to 4/3. Now we're ready to go to the X. To the X. Never go back to the X, guys. That's just asking for trouble. But I'm talking about this X, not the like your XX. Anyways, that's life lessons for you guys. Learn from others' mistakes. Do not go back to an X. That's just, yeah, it's bad news, period. You obviously are not together anymore for a reason. So just leave it in the past. Don't go back. Sine X, opposite over hypotenuse, so 9 over 15. So there's 9 over 15, that reduces to 3/5. So there's my 3/5. Cosine X, adjacent over hypotenuse, that's 12 over 15. 12 over 15, that reduces to 4/5. And then tan X, opposite over adjacent, 9 over 12. That reduces to 3/4. And there it is, guys. Not bad. I'm going to draw another happy face because we got another one we got it taken care of. That's an ear. That one looks kind of, you know what? That one, no. That one just looks, no. That one looks too weird. All right, let's keep going. So now we're into special right triangles. We have a 30, 60, 90 and a 45, 45, 90. And we already talked about these on Friday when we did the unit circle. But I guess we're going to talk about them one more time. And square root of 2. So on a right triangle where it's 45, 45, 90, you can also call that an isosceles right triangle. The legs are the same length, and the hypotenuse is whatever that length was times square root of 2. That you can derive it, guys. This one's pretty straightforward. You can also derive the 30, 60, 90, but the way I know how to derive it, I would need like a special grid. I forget the name of that grid, but it's not anything fancy, guys. So this is n squared, and there's another n squared. I want to know what the hypotenuse is, so this will give it to me. So square root of 2n squared. The square root of n squared is just n, so n squared of 2. And notice, that's what I have there. And then the hypotenuse is n squared of 2. So that's all we're going to do. We're just going to use our formula and n squared of 2. Or I guess you could technically use Pythagorean theorem. It doesn't matter, guys. So if this leg is 8, that means x it has to be 8 as well. Now, once you know that that leg is 8, then you know the hypotenuse is just going to be 8 times square root of 2. And there it is. That's it. It's that's straightforward, guys. This leg is 25, so you got to figure out what that leg is. So the y has to be 25 as well. And the hypotenuse has to be 25 square root of 2. Nothing crazy there, guys. On this one, we have to go backwards a little bit. So I'm going to go ahead and describe the 45, 45, 90. Degree, and square root of 2. So that 19 is the hypotenuse. So that means that 19 is described by the equation n square root of 2. And what you want to get n by itself. So let me rewrite it. N square root of 2 equals 19. So to get rid of the square root of 2, because you want to get n by itself, you just got to divide. Divide by square root of 2, divide by square root of 2. And you get n equals 19 divided by square root of 2. And you can leave it like that, but I think I think it's probably best if you rationalize the denominator. So rationalize means that you want to have a whole number in the denominator, because that's what it means. Rationalize the denominator. So multiply it by 1, and the number that you're going to multiply it by is square root of 2 over square root of 2. Whatever square root number you have down there, that's what you're going to multiply by, and you get 19 square root of 2 over 2, and that has to be what x and y are. 19 square root of 2 over 2. 19 square root of 2 over 2. And there it is, guys. Oh, I like that one. That's a nice happy face. How do we feel? Do we feel okay?
Yes.
Okay. Continuing. So we're going to do the 30, 60, 90 now. N squared of 3 and 2n. That's the relationship. The 30 degrees always makes a short leg, so this is what I'm going to use as a reference, so hence we put an n there. And then the long leg is always done by the 60 degrees, so then that's opposite of that, so that length here must be my long leg, so there's n squared of 3. And then the hypotenuse is always along the side, so I'm going to say that's 2n. So twice the short leg. So short leg is n, long leg is n square root of 3, and then the hypotenuse is twice your short leg. All right, I think we are ready, and let's keep going. So I have a 30, 60, 90 triangle right here. I know that my short leg is 5. So if my short leg is 5, that means my long leg, which is x, has to be 5 square root of 3. I'm just following the rules. And then my hypotenuse has to be double the short leg. That's my short leg here. That's my SL. So my y, the hypotenuse, has to be 10. Continuing again, 30 degrees, wherever opposite side that is, that's going to be your short leg. So my short leg is 14. So then that means my long leg, which is y, has to be 14 square root of 3. See? And then the x is the hypotenuse. So just double the 14. So that's going to be 28. Pretty straightforward, guys. This time they give you the hypotenuse. So knowing that, I guess I'll write the 30, 60, 90 right here. 30, 60, 90, and n squared root of 3 to n. So that 32 is like going down here. So it's like saying 2n equals 32. You want to figure out the short leg. We're going to divide by 2 both sides. Divide by 2, divide by 2. So my short leg is 16, which happens to be the x. And then to get the y, you just multiply that sucker by square root of 3. So 16 times square root of 3, and you are done. Another topic done. I think let's roll. I think we're ready to roll, miss. All right, so this one again is just another ratio. No big deal here on this one. It says in triangle VWX, the measure of angle X is 90 degrees. VX is 21, VWV is 29, and XW is 20. What ratio represents the cosine of angle W? So they don't give you a triangle, guys, so you're going to have to draw a triangle, not to scale. So whenever you see NTS, that means not to scale. So here's my right angle. They tell me that the right angle occurs at vertice X. So I'm going to call that vertice X. So that means I can write V and W on the others. So there's my VWX. So VX is 21. So VX is 21. WV is 29. WV is 29. XW is 20, so XW is 20. So there it is. I got 20, 21, 29. If you wanted to verify Pythagorean theorem that this is correct, it's correct, guys. 20 squared plus 21 squared does in fact equal 29 squared. So you're good there. And they want to know the ratio of cosine W. So here's W. So you write SOHCAHTOA. SOHCAHTOA. Once you're beast, you no longer have to write this, guys. That's just for now. And then once you write your SOHCAHTOA deal there, you just say, here's W. They want, what did they want ratio again? Cosine. So underline the cosine one. That's adjacent over hypotenuse. So I'm going to write cosine of W equals 20 over 29. And there it is, guys. Done. How do we feel? Do we feel okay?
Yes.
All right.
Yes.
Órale, qué padre. I wish I knew like 3 or 4 different languages. I have a buddy, a friend. His name is Kevin Wang. He's a pharmacist, and he knows 5 different languages. No joke. He knows English, he knows Spanish, he knows French, he knows Vietnamese, and like some other form of dialect of, I don't know. And every time he speaks all these languages, he always freaks me out. Like, man, how do you? He's just a really smart guy. All right, so let's see if we can do this one here, guys. They want to know what X is. It's 45, 45, 90. I'll do it 2 ways. 45, 45, 90. And square root of 2. And to figure out the length of that hypotenuse, I already know that one of the legs is square root of 3. So if I'm using this formula, that means I take my square root of 3 and I just multiply by square root of 2. So square root of 3 times square root of 2, that's going to be square root of 6. And there it is. Now, I'll do it another way. You could have always done it Pythagorean theorem. You could have always said square root of square root of 3 squared plus square root of 3 squared, and you would have still gotten the same answer. Square root of 3 squared is 3. Square root of 3 squared is 3 again. And you can see you get the same answer. So you're good. Let's put a unibrow on this guy. There you go. All right, let's go to the next one. Find the length of the side x in simplest radical form with a rational denominator. So this time they want to know what that dude is. This is a 30, 60, 90 triangle. So I'm just going to use the 30, 60, 90 triangle properties, n squared root of 3 and 2n. This side right here is your long leg, so that's square root of 2. So what you have here is n squared root of 3 equals square root of 2. So what you got to do to get n by itself, because you can't figure out what the hypotenuse is without knowing the short leg. So you got to get the short leg first. Divide by square root of 3, divide by square root of 3. So there it is. My short leg is square root of 2 over square root of 3. For now, you can leave it like that. If you want, you can just write one giant parenthesis and put one giant square root radicand and put the 2/3 in there, square root of 2/3, but that's fine. So from there, I'm just going to multiply by 2, guys. So 2 square root of 2 over square root of 3, which is an acceptable answer, but let's go ahead and rationalize the denominator. So I'm going to multiply the top and bottom by the square root of 3 over the square root of 3, which is the same thing as 1. So you're going to get 2 square root of 6 over 3. And there it is, guys. Now, before I continue, do we feel okay about that one?
Yes.
Okay. All right, let's go to the next one, guys. In triangle QRS, the measure of angle S is 90 degrees. So they're telling us what's 90, so it's angle S, vertex S. And then I can put Q and R. Angle Q is 61 degrees, so I'll put 61 degrees. QR is 79, so 79 feet. Find the length of RS, I'm going to put an X there, to the nearest foot. Okay, so this is a straightforward one. Chavez, I don't have a calculator. How do you expect me to do this? Well, if you're seeing this live, or I guess they're live because you're in Zoom, but if you're seeing this on YouTube, then you have all the tools necessary, guys. So here we go. With respect to 61 degrees, that X is opposite, and that 79 is hypotenuse. So opposite and hypotenuse is sine. So I'm going to write sine 61 degrees equals X over 79. And you're actually going to be doing like something like this in your physics class. And then from there, to get X by itself, you just multiply that sucker by 79. So 79 sine 61 degrees is going to give you your X value. So don't worry, we're going to show you how to do this without a calculator, guys. So let me share my Google here. There we go. So where it says graphing calculator, click on math tools. I don't want a graphing calculator, I just want a scientific calculator. So there's my calculator. And then I just type what I want. I already forgot what I want. What did I have, guys? What was the command? X equals what?
79 sine.
Sine of what?
61 degrees.
Okay, so 79, I typed it in, and then I pushed sine. There it is on my main. And then 61 degrees. Make sure you're in degree mode. It is. It's on degree mode. And there's my answer. 69.09495686. You're not going to type all those. I think it says round to the nearest foot. So we're going to put 69. So I'm going to go back to this guy. Hopefully everyone can see. And I'm going to say X equals 69 feet. If there's units, put units. Excuse me. How do we feel, guys? We feel okay?
Yeah.
All right, let's continue. Interstate 5 in California enters the San Joaquin Valley through a mountain pass called the Grapevine. Oh, that's cool. The road descends from an elevation of 3,500 feet above sea level, or I guess 3,500 feet, to 700 feet above sea level in a slant distance of 5.5 miles. Approximately what angle does the roadway make with the horizontal? All right, here's how you do it, guys. At one moment, you were 3,500 feet above sea level. At another moment, you were only 700 feet above sea level. So let me draw a triangle here. And then they want, what do they want? They want this angle, because that's the respect to the horizontal, so something flat. And this slant distance is 5.5 miles. Now understand, it was not always this smooth. Obviously, it was going up and down, but at a slant distance of 5.5 miles. So they want to know what that angle is in particular. So how do I do that? Well, my vertical displacement, 3,500 feet minus 700 feet, 5, 6, 7. I think that's 2,800 feet. So my vertical displacement is 2,800 feet. 28, 9, 1, 2, 3, 4, 5. Yeah, it is. Then what I need next, I want to make sure everything is in feet, guys. I need that 5.5 miles turned into feet. So someone do me a favor and take 5.5 and multiply it by 5,280 feet. It should be pretty close to 30,000 feet.
It's 29,040.
29,040 feet. Okay. And then I write SOHCAHTOA. And then I say, with respect to this angle, that 2,800 is opposite. That 2,940 is hypotenuse. So the only one that uses opposite and hypotenuse is sine. So then I'm going to write sine of that angle is equal to 2,800 divided by 29,040. Is everyone okay so far, guys?
Yes.
Yes.
Okay.
Yes.
The only way to get theta by itself, I don't want sine theta, I want theta. The only way to get theta by itself is to take the inverse of it. That's the only way you can get rid of that sine here. So I'll go theta has to equal inverse sine of whatever you have on the inside there. 2,800 over 29,040. And there it is. I got my theta. Do we understand that, guys? Or are we going to have issues there? Well, assuming we're going to have issues, huh? All right, let's talk about it. Let's talk about why we took the inverse. So maybe we're going to have issues with that inverse. Okay, so imagine that you have 5x. This is a side note. Just listen. Don't write any of this down. So imagine that you have 5x equals 15. So everyone knows that you would just divide by 5 to get the number. 5, 10, 15, that's x equals 3, and you're done. And really, I shouldn't be, this is probably a bad example, but we'll go ahead and just deal with it because it's the same concept, it's just different. So what if I told you you cannot divide? The only thing you can do is multiply. Well, I hope that you guys would tell me, well, I guess I would multiply by the reciprocal of 5. That's like saying 1/5, right? So I know this is not reciprocal, this is inverse, but it's the same concept. So you would say, okay, I'm going to multiply by that. And whatever you do to one side, you do to the other. And now these cancel out. And when you do this, which is, when it's a number, it's like saying reciprocal. But when it's a function, you got to say inverse because reciprocal and inverse are not the same. So there it is. And this will definitely get you 3. So the concept is kind of similar. So I want to get theta by itself. And the only way to get theta by itself is to take the inverse of sine. Now, does that make sense to you guys?
Yes.
Yes.
Okay. So write that down somewhere. The only way to get theta by itself is to take the inverse of whatever function I have. This symbol is called theta. There was a movie a long time ago. You probably, I don't know if you guys saw it. There, maybe it's called Stomp the Yard. I don't know. And they were coming out, and they were like, "Where the thetas? The thetas." Like, I don't know. I don't remember anymore, guys. Maybe they weren't the thetas. They were the betas, maybe. Oh well, too
I
bad.
think I know what movie you're talking about.
Yeah, they.
But
I
yeah,
think,
the sorority, they were called Thetas.
yeah, I think, yeah, and they were come out, and they were like stomping, and it was like all cool, and they're like, "Yeah, we're the thetas, we're the thetas," and then they did like a snaky sound, a snake sound, pss, 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 pss. And
Yeah, the movie is called Stepsisters.
it's stepsisters. I thought it was Stomp the Yard. Oh man, my
No.
movie trivia is totally off. All right, no big deal. Let's keep going, guys. So this one, we're doing the same thing. It says in triangle PQR, the measure of angle R is 90 degrees. So let's go ahead and draw a triangle, not to scale. Here's angle R, and then I'm gonna do P here and Q here. It doesn't matter what letter is what. And then QR is 8, so QR is 8 feet here. And then RP is 3.9, so RP is 3.9. Find the measure of angle P to the nearest degree. So here's angle P. Okay. Once you're beast, guys, you no longer have to do SOHCAHTOA. With respect to angle P, 8 is opposite and 3.9 is adjacent. So which one uses opposite and adjacent? The tangent one. So you're going to go tan of angle P, so whatever that is equal to 8 over 3.9. And again, just like I told you guys a little while ago, we want to take the inverse to get P by itself. So P is equal to inverse tan of 8 over 3.9. So I come back and I take my little calculator. So let me go back to Desmos. So Desmos, where are you? And here I am on Desmos. And then I'm just going to do that, guys. I look for inverse tan. No, that says tan there. So to find it, click on functions. And there it is, 10 to the negative 1. You click on that. And then I'm gonna type in there. I'm gonna go back to main. And I already forgot, short-term memory. What did I have in the top, guys?
8 over 3.9.
8 over 3.9. And there it is. So 64.0107. I think I just wanted nearest degree, so 64. So let me go back to my paper here. To the nearest degree, yep. So this gives me 64 degrees. So I'll just write P equals 64. Sometimes you'll see books that say this, and that just means measure angle P. It doesn't matter. If I see this, I'll count it right. If I see this, I'm like, oh, she's being formal, I'll count it right. It doesn't matter to me, guys. They're both, to me, I think they both mean the same. All right, here we go. Let's keep going. Oops. Triangle, nope. Triangle, nope. Triangle NOP is measured, and then angle P is a 90 degree. So here's angle P, and then here is N, and here is O. So there's no. And no is 55 feet long, and OP is 22 feet long. Find the measure of angle O to the nearest tenth of a degree. So here's measure angle O to the nearest tenth of a degree. I write SOHCAHTOA. So here we go. This is adjacent, that's hypotenuse. So we're ready. And I can just write what uses adjacent hypotenuse? Cosine. So I write cosine of angle O is equal to 22 over 55. And then I do inverse. So angle O is equal to inverse cosine of 22 over 55. You always got to have something in there. And then we're going to go back to my Desmos. And I'm going to make sure to type that in. So cosine, here we go. So I'm going to push enter, and I'm going to go functions, inverse cosine. And again, short-term memory. I already forgot what I had on the inside. Can someone hook me up?
22/55.
I'll push enter, and there it is, 66.4218. But I think this one said nearest tenth, if I remember correctly. So 66.4. So let me go back to this guy. And yeah, it says nearest tenth. So I'm going to write 66.4 degrees. And that's what O is. If you want to be formal, measure angle O equals 66.4 degrees. It means the same thing. Doesn't matter to me. You might see this on an SAT written like that. The M stands for measure, and then this guy means angle, and then that's O. And now I'm just telling you that the angle O is 66.4. So it doesn't matter to me, whichever one you prefer. And there it is, guys. So yeah, now let's come back.